Road to Olympiad.
Welcome to RTO. Consider the following problem. Find all integer n such that n to the power of 4 plus 6n cubed plus 11n squared plus 3n plus 31 is a perfect square. One common way to identify perfect square is by eliminating the answer through congruent modulo. But in this problem, we are going to use completing the square method to identify the answer. Pause the video if you like to give this problem a try, and when you are ready, keep watching to learn how to solve it. To solve this problem, we start by letting a to be equal to the given expressions. Notice that we can complete the square to obtain a is equal to n squared plus 3n plus 1 the whole thing square minus 3 times n minus 10. Clearly, if n is equal to 10, we have a is equal to 10 square plus 3 times 10 plus 1 the whole thing square, which is equal to 131 square, is a perfect square. If n is greater than 10, 3 times n minus 10 is positive. Thus, a is less than n squared plus 3n plus 1 the whole thing square. In order for a to be a perfect square, we need a to be at most n squared plus 3n the whole thing square. So we have n squared plus 3n plus 1 the whole thing square minus 3 times n minus 10 is less than or equal to n squared plus 3n the whole thing square, which can be rearranged into this one, and the left hand side can be simplified into 2n squared plus 6n plus 1 by using the difference between two square formulas, whereas the left hand side is simply equal to 3n minus 30. So, the inequality can be simplified into 2n squared plus 3n plus 31 is less than or equal to 0. However, this is impossible because when we try to complete the square for the quadratic expressions, we get 2 times n plus 3 over 4 square plus 239 over 16. This implies that the quadratic expressions will be always positive, and thus it is impossible to be less than or equal to 0. Now, for the case when n is less than 10, 3 times n minus 10 is negative, and thus a is greater than n squared plus 3n plus 1 the whole thing square. Here we consider two cases. For the first case, we have n is less than or equal to negative 3, or n is between 0 to 10 inclusive of 0, in which both this range will make n squared plus 3n to be greater than or equal to 0. Since a is greater than n squared plus 3n plus 1 the whole thing square, in order for a to be a perfect square, again we need to have a to be greater than or equal to n squared plus 3n plus 2 the whole thing square. That will give us n squared plus 3n plus 1 the whole thing square minus 3 times n minus 10 is greater than or equal to n squared plus 3n plus 2 the whole thing square. Similar to the calculation we did just now on the left, we can rearrange the equation this way, complete the square on the left hand side, and expand the right hand side to obtain this, which can be simplified into 2n squared plus 9n minus 27 is less than or equal to 0. Solving the inequality by using quadratic formula, we have n is between negative 3 times square root of 33 plus 3 the whole thing over 4 and 3 times square root of 33 minus 3 the whole thing over 4. Notice that the number on the left is greater than negative 7, whereas the number on the right is smaller than 3. Thus, this gives us 7 possible values of n, which are negative 6, negative 5, negative 4, negative 3, 0, 1, and 2. Notice that negative 2 and negative 1 is not included here because they are not in the range in our given conditions. For each of the value of n, we can easily compute the corresponding value of a to be 409, 166, 67, 40, 31, 52, and 145 respectively. Notice that none of these is a perfect square. For the second case, where n is between negative 3 and 0, we have the two values that we missed out just now, negative 2 they give us the corresponding value of a to be 37 and 34 respectively, which again are not a perfect square. Therefore, there's only one value of n that will make a perfect square. That is, n is equal to 10, and this marks the end of our solutions. Post in the comment below if you have any thoughts on the video, and if you haven't subscribed yet, consider subscribing. This will really help us out. Anyway, see you in the next video. Thank you.